Okay, so now that I'm recording, just again a few items. Don't forget tomorrow is your quiz. It'll have a linear and angular velocity problem on there, area of a sector, arc length on there, the S equals R theta. But the big one's going to be next week. Next week's going to be a short week anyway because you guys have a 3-day weekend. Remember, you don't come to school on Monday. So next time after Friday, I'll see you Tuesday. But Thursday, the 25th, will be your exam. Okay, because once we get Friday, we've only got 2 weeks left in the 6 weeks. So, time is starting to go by pretty quick. Before we know it, we're going to be getting out for Thanksgiving break and then for Christmas break. So it's going to be moving along nicely. Okay, well, let's get a little bit of background information before we get started. So the unit circle is a circle centered at the origin at the point 0, 0. Okay, so imagine, we have our coordinate system, the x and the y, and how we plot points in it. Well, what we're going to go ahead and do is take this circle and we're going to go ahead and put it right in the middle. Okay, so that from the origin to the circle itself, that's going to be the radius. We're just going to go ahead and plop this circle right down on top of the coordinate system. Okay, now since the equation of a circle is x minus h squared plus y minus k squared equals r squared, where h and k is the center of the circle and r is the radius, we can then have this. Because both h and k are 0, we can say x squared plus y squared is equal to 1. Okay, because on the unit circle, the reason we call it the unit circle is because the radius is just 1 unit. Okay, so 1 squared is going to give me 1. Now, some people do like to go ahead and incorporate the zeros in the equation, and that's perfectly fine. You could say like x minus 0 squared plus y minus 0 squared is equal to 1 if you actually wanted to go ahead and show those. Okay, some people do, some people don't. Now, the circumference of a circle is found by using the formula, and we actually just did this on a previous problem. It was 2 what? 2 pi r. 2 pi times the radius, right? Now, because the radius of the unit circle is 1, well, then the circumference is just going to be 2 pi times 1, well, just 2 pi. I think about it, that really kind of makes sense because we've been saying for a while now, what's 1 revolution in radians? It's 2 pi, that distance around the circle. Okay, now let's go ahead and start talking about degrees. When measured in degrees, 1 full revolution is equal to 360. Okay, we know that. Now, if we split the circle into 4 equal parts, like we did here, using the axes, then at each corner, okay, each one of these is going to go up by what? 90 degrees. Basically, 360 divided by 4. Okay, if we split the circle into 8 equal parts, then it's going to be 45, yes. 45 degrees. Now, if we split the circle into 12 equal parts, it's going to be 30. 360 divided by 12 would be 30 degrees. That's exactly right. Now, we're going to use those two, the 30 and the 45 degrees, to actually help me when it comes to the radian measures. Okay, so here we go. Let's go ahead and take a look at this guy. That's bright green. Now, you'll notice I gave you a copy of this on cardstock because this one, pretty much everything we do for the rest of the year in some way or another is going to involve trigonometry. So I went ahead and put this on cardstock. It's more durable. It's going to last longer so that you can keep it in your notes. And I put it on a bright green color so that you can easily see it immediately when you're looking for it. Okay. Now the other one, this is just for your benefit. I just went ahead and gave you just a blank copy on normal paper, just so you can practice the unit circle. Okay, you do want to be familiar with it. We want to be able to recreate it. Okay, so there are 3 parts to creating the unit circle. Now, the good news is, for a good while, we're only going to be looking at these 16 points. So 1, 2, 3, 4, 5, 6, all the way around. Now, there's an infinite number of points on a circle, but eventually we're going to go ahead and get there. We're going to start to expand to others. But right now, we just need to set the groundwork for what we're doing. So we're only doing these 16. So the 3 parts, you need the degree measures, then you need the radian measures, and then you need to know the actual coordinate, the XY coordinate of each of those 16. Okay? So we're going to go ahead and start out with the degrees. We're going to make it real easy first. because the last one is going to be the coordinates. That's probably the toughest. Now, I shouldn't even really say the toughest. It's just not as straightforward as the degrees are. So let's go ahead and start here. We know 0 degrees. All the way around is 360. Okay. So what's a quarter of a revolution? That's 90 degrees. Then half, 180. And you remember we've seen these before when we've done some problems. 3/4, 270 degrees. And all the way back around plus 90, there's my 360. Okay. So now you'll notice in each of the 4 quadrants, you've got a cluster of 3 points. Okay. These points are the same distance from each other. Okay. Now in the cluster, they're 15 degrees from each other, but their ends are 30 degrees from the nearest axis. Okay. So if right here I'm going to start, now remember what would we call it when I started rotating on the positive x-axis? Remember that was my what position? Standard position. So I'm going to start to rotate, right? Well, in order to get to the first point, I got to rotate 30 degrees. But now remember, these clusters, they're only 15 degrees away from each other. So 30 plus 15 is 45. Plus 15, 60. Now to get to the axis, I'm going to add 30. And see, now we're at 90. Okay. Now to get to the next point, I'm going to add 30. So what's 90 plus 30? 120. And remember, even here in the other quadrant, those are 15 degrees from each other. So 135, that's 120 plus 15. Plus 15. 150. And you'll notice how far is it to get to the 180? 30. So you add 30 to get to the axis again. And you just keep that pattern going all the way around. Okay? The closest points are 15 degrees away from each other, but the points themselves are 30 degrees from the axes. So what would this one right here be? 210, 180 plus 30. So 210 degrees plus 15. 225 degrees plus 15. 240 degrees. And you'll notice again what happens. Plus 30, there's my 270. Okay? So now what am I going to add to 270? Add 30 again, which gives me 300 plus 15, 330. And then again, check it. 330 plus 30 gives me my last rotation around. So there's all your degrees. Right there, that's 1/3 of the unit circle. Okay. So typically, everybody's really good with the degrees. That usually doesn't cause any issues. Anybody have any questions on that? Okay. Now, for the same 16 points, I want to have the radian measure as well. Okay. So the one thing you don't want to do, because time is a factor, you don't want to take all of these individually and multiply by pi over 180. I mean, you could, but it's going to take a while, right? So there's a better way to do it. If your degree measure is a multiple, if it's a multiple of 45 degrees, count by 1/4. Okay. And I'll show you what I mean by that. Okay. If it's a multiple of 45 degrees, I'm going to count by 1/4. I'm just going to keep adding to it. If it's a multiple of 30 degrees, I'm going to count by 1/6. Okay. Now, what I mean by, counting by fourths, counting by sixths, like for example, let's say we want to count by fourths. So it would be 1/4, 2/4, 3/4, 4/4, 5/4, and you would just keep the pattern going. You're going to count by fourths or you're going to count by sixths. Okay. Well, let's go back up to the unit circle. Help me identify what are all the angles that'll be a multiple of 45. Okay, so 90 is one of them. Okay, 135. 45, isn't that a multiple of 45? Okay, 180. 225. 270. 315. and then 360, right? So if it's a multiple of 45, just start counting by the fourths. So 45 would be 1/4 pi. So pi over 4. 90 would be 2/4 pi, right? But what's 2/4? 1/2. So wouldn't that just be pi over 2? Then we're at 3 pi over 4. If it can be reduced, yes, go ahead and reduce it. Okay. And then now when you get to 180, well, wouldn't that be 4 pi over 4? Yeah, so that's just pi. So see, don't take the time to go ahead and change all of these by pi over 180. Just count. So what number am I on? Okay, so we just finished up the fourth one. So 225 would be 5 pi over 4. Now, we always know down here, this will be 3/2 pi, right? 3 pi over 2. Well, we just finished up 5 pi over 4. This would be 6 pi over 4. And what is 6/4 reduced to? It becomes 3/2. So this is 3 pi over 2. So what number are we on now? Let's see, we did 1, 2, 3, 4, 5, 6. So now we're on 7 pi over 4. And then when I get all the way back around to the end, well, I would have 8 pi over 4, but what's that? There's your 2 pi. There you go. Does everybody see how I did that? Just count by fourths if it's a multiple of 45. Now, if it's a multiple of 30, we're going to do the same thing, but we're going to count by sixths. Okay? So let me do this in a different color. Okay. Probably something that'll stand out. Let's say blue. Okay. So help me identify what are all the multiples of 30. So definitely 30, 60, 90, 20, 10, 240. Okay. Am I missing any? 330. And then all the way back around to 360, right? Okay. So 30 degrees, I'm going to start with 1/6. So this would be pi over 6. Then move to the very next one. Now this one here would be 2 pi over 6, right? But what does 2/6 become? Yeah. So that's pi over 3, or 1/3 pi. Now watch, it's going to match up for the ones we already have. See, I did 1 pi over 6, 2 pi over 6. This one would be 3 pi over 6. But what's 3/6? 1/2, and we already have it as pi over 2. Now help me as we go around. What would 120 be? What are we at to right now? We're at 4. So this would be 4 pi over 6. So what's 4/6? 2/3. So this would be 2 pi over 3. Now we're to 5 pi over 6. You can see we're counting. 1 pi over 6, 2 pi over 6, 3 pi, 4 pi, 5 pi over 6. Okay? You're just counting by 6. And then we get around, the same thing's going to happen when we had 4 pi over 4. I now have 6 pi over 6. But again, those cancel, and I still have just pi. So what would 210 be? It'd be 7 pi over 6. There you go. Next one, what's 240? 8 pi over 6. So 8/6 is 4/3. So this would be 4 pi over 3. Now we have 9 pi over 6. But what's 9 over 6? 3/2. See, we already have it. Now what number are we up to? 10. So 10 pi over 6, that's 5/3. So this would be 5 pi over 3. Then 330. 11 pi over 6. And then see, we get all the way back around to 12 pi over 6. But what's 12 divided by 6? There's your 2 pi, which you already have. That's the radians. Okay. And see, this is the thing about the unit circle. Even I don't have it memorized. I don't think there's a need to have it memorized. If you feel you want to do that, I always have students who say they're going to, so please feel free. But I think it's so much easier to just create it based on the patterns. If you know that, you don't have to memorize that whole thing. Okay? What do you think? Hmm? Okay. We'll pick it up again tomorrow because we've almost got the full unit circle. Okay. All we need now are to find the coordinates of all these points. And I've got shortcuts to help you with that as well. Very easy. Okay. So we'll go ahead and stop there. Thank you very much, guys. Once again, you did a fantastic job. I appreciate it.